Okay, my lovely, lovely stats students, we're back for another episode of the playthrough of Stats Medic. We're looking at lesson 10.1, day 2 this time. It just has to do with Twitter, which is really nice for us. So, here we go. 10.2, 10.1, day 2. Let's get this done. Okay, so we have a recent sample of 200 US females revealed that 110 use Twitter regularly. A separate random sample of 150 males revealed that 60 of those use Twitter regularly. Construct a 95% confidence interval for the true difference in proportion. We're going to do female minus male. So first off, we're supposed to write down our parameter. So our parameter here would be P1 or P female minus the proportion of males. Okay, so I recommend that you write subscripts that make sense. I know a lot of books and stuff say P1, P2, which is fine and all, but if you're allowed to be descriptive, why not be descriptive here? Where PF is equal to the true proportion I think I misspelled that way wrong. Proportion of females using Twitter, and P male is equal to the true proportion of males using Twitter. Our statistic here is going to be P female hat minus P male hat. Okay, and there's actually a number for that. The number is 110 out of 200 minus 60 out of 150. We'll get a calculator and calculate that real quick. Let's try Alexa. Computer, what's 110 divided by 200 minus 60 divided by 150? If this works.
110 divided by 200 minus 60 divided by 150 is 0.15.
Ooh, 0.15. Okay.
The answer to your calculation is 0.15.
Thank you.
Anytime.
Wow. Okay, so
Enjoy
that
your evening.
that worked. Crazy. Construct a 95% confidence interval. So our confidence level is 95%. Okay. Moving on. Name the procedure. This is a 2-sample Z interval for props. Or I guess you're going to see it as P1 minus P2. Okay, so let's check our conditions now. I'm having a hard time finding, oh, there it is. Check our conditions. Number 1, does this say random anywhere? There we go. Does this say random? Yeah, this says random samples. Random samples. Number 2, 10% condition. Are there more than, so 10 and 1 is equal to 2,000. Are there more than 2,000 female Twitter users? I think that's true. How about 10 times n2? That's equal to 1,500. And yeah, there are more than 2,000 female and 1,500 males using Twitter. Okay, you can get that in a couple of high schools. you're already good there. So yeah, that definitely makes sense. And what about the last one, the large counts? Okay, so large counts would be N1, in this case NF times PF hat, and that's equal to 110. That's greater than equal to 10. There's NF hat QF hat, and that's going to be equal to 90. That's also greater than equal to 10. And then we got to check for males. So NM hat, no, there's no hat with N. N, let me get rid of those hats. Those look stupid. No hats for N. And now there's no N at all. Okay. Let's reconstruct that. NF. So NM times PM hat, that's equal to, right here, 60. That's greater than equal to 10. How about NM QM hat? That's equal to, let's see, 110 minus 60 is 50. So yeah, that's greater than equal to 10. So we're all good. We got the large counts, we've got the 10%, we've got random samples, and we are off to the do. While we're talking about it, I am seeing, if you were one of those people who religiously did all of 10 of those hypothesis tests from last chapter, you are cruising right now, because this is right up your alley. If you're one of those people who kind of cheated yourself out of that experience, I mean, I don't know what to say. These are all learning experiences for you, and you're kind of cheating yourself out of your learning experience. Far beyond getting your grades here, I'm here to teach you some stats. So let's just move on. That's enough of my lecturing for you. How about the general formula for any confidence interval? That's a point estimate plus or minus the margin of error. Specific formula. So our point estimate, this is where we should be taking notes. That's going to be P1 hat minus P2 hat plus or minus square root of, let's see, that's P1 hat Q1 hat over N1 plus P2 hat Q2 hat over N2. Okay guys, coming back, I forgot to put our z-stars in here. That's kind of embarrassing. But here we go. For the margin of error, it is z-star times this standard error here. Z-star is 1.96. Get all of that in there, and now we're ready to look at it in the calculator. Yeah, so 1.96 multiplied by this beast gets us 0.1158. So 0.1158. Okay, and how does that do us? Yeah, that's it. I'm looking at this and I think we're making a big mistake here. Wasn't this 150? I think this was 150. I think we're going to have to redo a whole lot of this. So give me a second. We're going to go ahead and do that right now. Duh, so everything here is off. Let's redo our point estimate. Get our calculator back. Doesn't want to come back. Yeah, let's get our calculator back. And 60 out of 150. All right, that's going to make that look a little better. 0.15. Oh, wow, that's a lot nicer. 0.15. 0.15. Okay, so now we're going to calculate, we're going to interpret this in context of the problem. So the true proportion, or the true difference in proportion, let's write that down here. This font is a little big. Let's scale it down. So the true difference in proportions, of female and male Twitter users is between, let's do this first one. Here comes my Alexa. Computer, what's 0.15 minus 0.1044?
Minus 0.1044 is 0.0456.
Computer, what is 0.15 plus 0.1044? Computer, what is Computer, what is 0.15 plus 0.1044?
0.15 plus 0.1044 is 0.2544.
Okay. So now we can talk about the consequences of this. We know for sure that female users use, a higher proportion of female users use Twitter than males. I don't think I said that right, but a higher proportion of females use Twitter than males. How can I say that? Well, this entire confidence interval is positive, which means that all the plausible values for the difference in this proportion is positive. So even at the low end, females use Twitter. The proportion of female users who use Twitter is at 5% greater than male. So if you have an interval where everything is positive, then you're looking at that first proportion is going to be bigger than the second proportion. That's the interpretation of this interval. Likewise, if your entire interval is negative, well then that means that if the entire interval is negative, then all of your second proportion, in this case are males, that means we know that the male proportion is bigger than the female proportion. And what if you have some negative and some positive? Well, that means that you can't tell which proportion is greater than the other one. That means that the interval is inconclusive, if you want to look at it that way. But another way to look at it is it's possible that those two proportions are equal to each other. Because if you have negative and positive, then one of the plausible values in there has to be 0. So you can actually show that it's plausible that, in this case, the proportion of female Twitter users is equal to the proportion of male Twitter users. But of course, that's not how our numbers came out. Our numbers came out with female users, or females use Twitter in a higher proportion than males do. Okay, let's get back to that problem. Here we go. Looking over here at our important ideas. Learning target 1 is about that 2 sample z interval. We got P1 minus P2 is a true difference in proportions. The statistic is those hats subtracted. And I did it again. I forgot z star. How improbable that I would forget z star. There we go. Z star times that standard error. Interpretation is all that stuff that we talked about before. If you want to pause it here and copy this down, you can pause it in 1, 2, 3. Okay, that's probably enough time for you to pause it. Let's take a look at the check your understandings. The Pew Research Center poll recently asked independent random samples of working men and women how much they value their job security. Of the 806 women, 709 said job security was very important, compared to 802 out of 944 of the men surveyed. Construct and interpret a 95% confidence interval in the difference of proportion of all working men and women who value job security, who consider job security very or extremely important. So we're going to do the same thing. We're going to do state. Okay, so PF is a true proportion of females who value job security. Okay, we're not going to make a big deal about it. PF is going to be equal to the true proportion of males who value job security. Okay, so our parameter then is PF minus PM. Our statistic is X bar F minus X bar. Why am I using X bar? P hat F minus P hat M, which is equal to, what is that? 709 out of 806 minus 802 out of 944. Let's get a number for that real quick, computer. What is 709 divided by 806 minus 802 divided by 944?
709 divided by 8 is 88.625.
Okay, well, you botched that up. Let's get our calculator out. Okay, there's our calculator. There's our statistic. It's 0301. Great, that's our state plan. Okay, this is called a two-sample z-interval for P1 minus P2. Okay, conditions. Do we have random samples? Yeah, we have random samples. %% condition. Okay, are there more than, so we have 806, so 10 times NF is equal to 8060. 10 times NM, that's going to be 9440. Okay, so yeah, this is conceivable that there are more than 80, 60, and 9,440 working women and men, respectively. Okay, so that takes care of that. How about large counts? Let's see. NF times PF, that's going to equal to 709. That's definitely greater than or equal to 10. NF times QF, these are hats, that's going to equal to, oh, now my subtraction, what is that, 97? That's greater than or equal to 10, okay. nm times pm hat, that's going to be equal to 802, certainly greater than equal to 10. And then nm pm hat, that's going to be equal to, what is that, 142? Definitely greater than equal to 10. So we're good to go with this normal distribution. Okay, time to do the do. I can't believe I said that. I'm sorry. I apologize for that horrible. We have the general formula is point estimate plus or minus the margin of error. Our specific formula here is PF minus PM plus or minus, I think we said a 90% confidence interval. I want to be faithful to this. 95% confidence interval. Okay, so our 95% confidence interval is 1 point, no, we should be putting a z star here. Z star square root of PF hat QF hat over NF plus PM hat QM hat over NM. Shoot it up over here. Let's substitute our numbers. Our numbers are 709 out of 806 minus 802 out of 944 plus or minus 1.96, a good one to memorize. And then we're going to put those numbers in again. So 709 out of 806 multiplied by 97 out of 806 divided by 806 plus 802 out of 944 multiplied by 142 out of 944 divided by 944. Let's grab our calculator and do some magic. Okay. Firstly, we already did this part of it. It's 0.0301. Now we have to get the margin of error, and that was 1.96 multiplied by a square root that's not a square root, 1.96 multiplied by the square root of, let's get a fraction bar, 709 out of 806 times 97 on 806 all on 806 plus more fraction bars, okay, that's 802 over 944 multiplied by 142 over 944. The whole thing over 944. What does that give us? 0.032. 0.032. So plus or minus 0.032. Time to interpret this guy. We're running out of room here on this, so let's see. That's not a good place to type it. Let's type it there. Yeah, that's a good place to type. Again, let's go down in font size here. Okay. We are 95% confident that the true difference in proportion between females and males who value job security. I just realized this is kind of going off the screen. Who value job security is between computer. What's 0.0301 minus 0.032?
0.0301 minus 0.032 is minus 0.0019.
And computer, what is 0.03?
Here's something I found on the web.
Computer, what is 0.0301 plus 0.032?
0.0301 plus 0.032 is 0.0621.
Okay, and that is our proportion. So there it is, everybody. Okay, that's been our chapter 10.1, day 2 playthrough. Hopefully you enjoyed that. And I will see you. Next for you is your homework assignment. So have fun. See you next time.